Hello, and welcome to our webinar, PaaS, Platform as a Service, bringing the power of maps and location and services to your apps. My name is Scott Ward. My colleagues Linda Peters, Adam Pfister, and Matt Barra will be your hosts. First, I'd like to cover some administrative details. You can ask questions through the question module, and we'll answer those at the end. The recording for this webinar will be posted early next week if you'd like to review it in the future. With that, we'll get started, and I'll hand this off to Linda.
Thank you so much, Scott. Really appreciate it. And thanks to all of you for being here today. I'm going to turn the camera off just to save bandwidth here and dive us in because we've got a lot of content to go over today. So a short agenda for us, but a lot really to cover. As Scott mentioned, we're here to talk about platform as a service. We'll spend some time talking about the capabilities of the platform and then take a deep dive into how it works. We'll have a really good set of demonstrations from my colleague Adam Pfister, and then Matt Barra, who's also with us today, will join us at the end for a round of Q&A. So please keep those questions at the ready. You can start to put them in the question box along the way, and we'll come back to them at the end. So with that, I want us to dive right in. Many of you here are likely familiar with the ArcGIS system. You're probably familiar with ArcGIS Online, with Pro, right? It's a powerful desktop application, and even with Enterprise. But today we're here really to talk about this new idea of ArcGIS Platform. We're really kind of pulling back the curtain and offering the underlying services and power of ArcGIS to you, to your developers, through a platform as a service offering. And this allows you to build mapping and location-based applications. It really is a new developer experience. It's for people who need direct access to location and location services and content, including the open source mapping community. It's really a different way to build. So I'm going to challenge you to, as we go through the day, think about how you could include this in your work. It also allows you to include other things like Mapbox or Leaflet or open layers. It provides a new way to authenticate through industry standard API key authentication, and Adam will go through that in detail. And then all of that is offered through a new business model as well. So really a lot to cover here today. So the big question is, why is Esri introducing these new options for developers? And that's a really important question because we recognize that developers like you realize the value, the meaning that maps can bring to your solution. And we all want to use the best of breed location services and capability and easily integrate them into our solutions. And using open source mapping libraries is important to all of us because they give us flexibility and control we need in the development process. And we want to be transparent and have things that are easy to understand, like this new business model that I'll touch on again shortly. But above all, we want to help you build engaging applications and solutions that inspire action. So let's take a look at how we can begin to think about doing this. ArcGIS users today have developed apps and solutions using our software and software as a service for many years. But with the platform, we're enabling this broader community of developers to use maps and location to build solutions. These live interactive apps are engaging, they're dynamic, they're purposeful. They bring together stunning visualizations, valuable visualizations that can help us uncover patterns and relationships. And they leverage beautiful cartographic maps and analytical capabilities, right? We're exposing all of the data layers and things that you're used to using every day. Now, this is really made up of three elements: the developer experience, and we'll spend a lot of time on this today. This will help you be successful by giving you access to the APIs and the ability to use and choose the mapping library of your choice. The centerpiece of the platform, though, is the comprehensive set of location services that we have that deliver content and capabilities. So we'll take quite a deep look at that as well. And then again, I mentioned that business model, right? This simple, transparent, and easy to understand business model that allows you to consume what you need and only pay for what you use. All of these elements come together to provide this new experience. Now, when we think about the developer experience, we think about APIs. The platform comes with a robust JavaScript API for web development and a set of APIs for mobile and desktop development as well, and scripting APIs that enable you to automate your mapping and analytics. Adam, again, will go into more details on things like this and authentication resources and tools in just a few minutes. When we talk about location services, there are so many things to talk about. These services can be used in many different deployment patterns, again, from web to mobile to desktop, even system to system integration. You've got access to the high quality location services, maps, data, geocoding services, all of the things that you're used to using if you're an Esri ArcGIS user today. The powerful data is there for visualization as well as routing and geocoding and spatial analytics. And again, we'll touch on all of those. And of course, this third element, the business model, getting access to the platform is as easy as signing up for an account. There's a free account available right now on the developer site. In addition to that developer experience, there's that extensive set of location services. You'll receive a free tier, if you will, a kickstart to your development that includes 2 million map tiles per month and thousands of service requests. So we want to make it easy for you to get started and understand how things work. And then there's also, again, a transparent consumption-based model. We'll share some links and things at the end so you can go out and see what that looks like. But I don't want to hold us up because there is so much content to go through. So I'm going to invite my colleague to present on some of the ideas. But before we do that, I think, Scott, and why don't we start out maybe with the first poll question? Can I kick it over to you?
Sure. We'd like to find out, are you considering using platform as a service? Is this something that you're ready now? Is this something that you plan to implement in the next 12 months? Or is it something you're still researching and it might take more than a year to decide whether it's right for you or not? Or do you have no current plan and really this is just more of a informational thing for you and we just want to get a sense of where you are with platform as a service? Seems like a lot are doing some research, and then some of you are ready or ready in the next year or so.
Great, thank you, Scott. So with that, I want to kick it over and have us begin to take a little bit of a deep dive on the platform itself. So here we go.
Thanks, Linda. I'd like to spend some time now looking at some of these location services in a bit more detail. To begin, let's start at the ArcGIS Developers site. When you visit the ArcGIS Developers site, you'll find a library of resources and tools to help you be successful, and you'll notice that there have been some significant improvements. For example, we have a brand new developer guide that is your authoritative source no matter how you develop with ArcGIS. You could be working with services from ArcGIS Platform, building apps that integrate with ArcGIS Online, developing solutions using our Builder technology, or extending and automating ArcGIS Pro and Enterprise. Additionally, the developer site has an extensive SDK documentation that includes both conceptual and API reference for all of our mapping libraries. The site includes over 100 tutorials with a live sandbox that you can code against and see updates instantly. Let's get started by visiting our developer dashboard. Now, the developer dashboard is designed to help you accelerate in your onboarding and give you a personalized experience where you can easily access only the resources that you're interested in. You can tailor it to what you do and the tech that you use. You can have additional controls and insight into the usage of your solutions. You'll also be able to get detailed information at the transaction level for all the services that you may be using. On the homepage of the developer dashboard, you get a quick glance of your information, things like your API keys, recent hosted layers, or other applications that you've set up already. There's quick links at the top to get you a quick access to things like downloads for different APIs and SDKs, as well as even to generate an API key. Let's do that now. Let's say I want to create a new API key, and we'll use that for some location services testing. We give it a name, an optional description, and click Create, and we now have an API key that's ready to go. Now I can drop that into an application right away, but if I'm just getting started, I also have access to code samples that show me right away how I could actually create and use this API key. So here we're looking at an example using Mapbox GL.js. You could also switch that to use an Esri Leaflet example, or the ArcGIS JavaScript API, or if you're building a mobile application for iOS, you can see the code sample that you would need to use that API key in your mobile app. What's most important is that you configure your API key for use in different services. Right now, we want to use it for geocoding. We could use it for routing. We could also use it for things like creating service areas, or even enriching our data with different demographic information. Now that my API key is set up and ready to go, let's look at creating some layers right from the developer dashboard. From here, I can choose to import data, and I'll select a CSV file on my machine. I'll drop it into the page, and I'll begin the upload process. Now in my CSV file of trailheads in the Southern California area, I have an X and a Y column that we can map to our latitude and longitude columns. What this will tell ArcGIS is to take those columns, plot them on the map, and turn those into points that we can visualize. The process just takes a few seconds, and right away we have some information that is going to be helpful to us as developers. We have the item ID that we can choose to copy, the layer URL. Again, we can choose to copy that right into the browser. We can even zoom in and see our points on the map and get a quick preview of where they are located and verify that they all came in correctly. If we're interested in sharing the information right away, we can choose to make that public. And now it's publicly available for all to see. We can also enable editing on the layer and choose whether or not we want to let people download through data export and update some other pieces of metadata about the layer itself. The second type of layer that you can create from the developer dashboard is called a vector basemap layer style. Choosing this option launches you into the vector tile style editor web application. Here on the left-hand side, we have a number of pre-built Esri basemaps that we can choose to use as a starting point. These are some of the more popular basemaps, but you can also choose some of the creative styles, such as this modern antique. Choosing a layer style will bring it into the map, and we can see that the land is represented by a certain color, water, roads, and each to their own. If I wanted to change one of these colors and see how it's represented in the map, all I need to do is simply drag the color to a different spot, and I can see that automatically is updated on the map. Now I have a global view that I can see the water change pretty easily, but I also have 3 views on the bottom, one at country, one at city, and one at street view. If I want to change the roads, I can just do the same thing as well. I can change to different shades, see how those might look. And once I'm set, I click Save, and this style has been locked in for me, and I can then use it in other applications. Now I've gone ahead and created one for us that we can use in future demonstrations, and I've used that modern antique map, and I've just made it a shade of dark green. Now for each one of the location services in the ArcGIS platform, you'll find an overview page that will walk you through some of the key features and functions of how it works, along with anything specific to that particular service that you'll need to know about. One thing I wanted to draw your attention to with our basemap service is the data associated with it. Now, since it is a global service, we use a lot of different providers depending on where you are in the world and where you're looking. The detail and accuracy will also vary depending on the location of the world. You can use maps in different projections. Most of our layers are published in the Web Mercator projection, but you can also include languages that vary depending on the locale for the users. You have a lot of control over how you present the base maps and how you get up and running quickly. Let's now take a look at a sample of code that we can use to create a simple mapping application. I'm first going to go back and grab an API key that we can use with our application. On the left-hand side of the screen, you'll see the code sample, and on the right-hand side, you'll see the output. Right now, we just have a blank map that shows a little bit of the topography of the world. Once we insert our API key and click Save, our application updates, and we're now using our API key to display our base maps. I can change from topographic to streets by simply changing the name in the code. I can use the OpenStreetMap versions. But as we're developers, we're building apps for our users to use. So we don't want to have them to go through code. We actually want them to interact with our application. And to do that, we'll add in a few widgets. In the Esri JavaScript API, there's a wealth of widgets that are pre-built, ready to wire up to your data that you can use. So I'll paste in a code sample, and I'll save my application. And what we've just done is we've added in two widgets specifically for use with the base maps. The first one is this base map toggle. This comes in the bottom right-hand corner. And all that's going to do is switch between the most recently selected base map imagery layer, and in this case, the ArcGIS imagery layer. And that's good for a quick comparison between two layers. The second one is this base map gallery widget, and that comes in up here in the top right. And this is something that most users are familiar with, allowing them to browse all the different base maps available to them and simply point, click, and select the base map. Now this is great, but we also created a vector base map layer style. So how do we use that as part of this application? Well, just through a little bit more code, we can actually reference our modern antique copy that we made, that green copy, and we'll say load that in addition to all the other pre-made styles. And all the way at the bottom, we should see our green modern antique layer ready for us to use in our application. Now, as you've seen, you can go through a high level of customization for a base map. But as you do so, I'd encourage you to keep in mind your audience and to always keep in mind the accessibility of your base map. So to that end, some of our colleagues here at Esri have put out a number of helpful tips and blog posts to how to make accessible base maps. So I'd encourage you to look at these resources, review them, even preview them and see how they might look and how you may fit them into your applications, even providing them as options. The location services from ArcGIS Platform deliver billions of base map views around the world on a daily basis, and you could take advantage of them today. From base maps, let's move on to talk about geocoding and search as part of the ArcGIS Platform. The ability to find addresses and points of interest is common in most mapping applications. Our geocoding service is powered by industry-leading reference data that comes from multiple authoritative sources, much like our base maps, that include commercial data providers, government agencies, and our network of partners all around the world. So this ensures that you get the most accurate search results. The search service also supports local languages and address formats. On the geocoding service overview page, you can find more information about the service itself, including some more key features, and the core operations that you would use the geocoding service for. The first being getting a location from an address, a place search, reverse geocoding, autosuggest, and batch geocoding. These operations can all work together to help you provide a powerful end user experience. With regards to service data and quality, it will vary once again by region of the world, along with multiple languages and quality. Let's take a look at how we can use this geocoding service in an application. Here we have a very simple application showing a map of the world, and we've configured our API key. We chose to use the ArcGIS navigation style as our base map, and our map is going to start at the center of the world at the second zoom level. Now to let our users take advantage of these search services, we can add in a widget that's provided by the JavaScript API. So I'll paste in some code, very simple, only about 4 or 5 lines of code, that says we want to use a new search widget, tie it to the view of the map, and add it to the top right corner of the page. Now this may seem pretty basic, but it is wrapping out a lot of very powerful features and functions into a few lines of code and an even simpler user experience. Now as I begin to type in an address, a city, a state, I immediately see suggestions prompted, allowing me to choose my particular location. The map automatically zooms and pans to that location, and the user is centered around their intended spot. The second example I'd like to show is using Leaflet. So the Esri plugin for Leaflet allows you to work directly with the Leaflet mapping API and incorporate things like the base map service, and in this case, the search control service. Now you can see we've got a little bit more code already in place for us to view this example. I'm using a search control that's added to the map in the top right corner. And you can see that here with the search magnifying glass. And we're saying whenever we get results on the map for what we're searching for, clear out anything that's on the map previously and simply add a pop-up to the map showing those locations. So I'll do a simple search and I'll start to type in something like Paris. Now I know we're in Sydney, Australia, as the map shows, and I'm typing Paris on purpose because what I'd like to show you is how powerful the search control can be if you choose to configure it this way. Notice that we're seeing results that are local to the Sydney area, but we're also seeing a result right in the middle for Paris, France. Now, likely our users aren't going to be searching for Paris, France if they're zoomed in this far into Sydney, Australia. We can help them a little bit by removing these options and have our map only search for locations that are currently within the map bounds. To do that, we'll change this use map bounds property from false to true, save, and when the app reloads, we'll try our search again. Type in Paris, and now we don't see anything related to Paris, France, or any other location. I know you may see Paris, Texas down here, but that actually is a spot in Sydney. So with a few changes, a couple lines of code, I have now provided context to the user and provided them with only relevant information for them to search for. I'd like to show you an example now of how you can use a search widget to not only search through the ArcGIS Online World Geocoding service, but also through your own data sets. And to do that, I've created a map application using our API key and our custom vector tile layer, along with the trailheads layer that we previously published in our developer dashboard. Now to represent where those layers are, we can type in the name of a city, in this case Thousand Oaks, California, and we only see results that are coming from the ArcGIS Online World Geocoding service. Now say I also wanted to provide an experience to the user that let them type in the name of a trailhead and see that results in that top right widget as well. Well, to do that, it's as simple as adding in a source to the search widget that says I want to use the trailheads as a particular layer to search for, and I want the layer to be able to type in the name of the trail and show that back to them. So once we add that into our code, we hit save, and we begin our application once again. Let's zoom in to Thousand Oaks. And now we have a banner at the top saying these are results coming from the ArcGIS World Geocoding service. That gets us to our area of interest where we can see our trailheads. And now if we type in the name of a trail, we can see that we have that listed in our results as well. So Willow Creek Trail, it's located in the California State Parks in Leo Carrillo. Through just a few lines of code, you can customize the out-of-the-box widgets to not only search the existing Esri provided services, but also throughout your own data as well. The next location service is routing and directions. Routing and directions has the ability to perform both routing, turn-by-turn directions, as well as much, much more. This helps increase the overall efficiency of daily workflows. In addition to common point-to-point routing, you can route multiple vehicles to multiple destinations. And like the geocoding service, the routing service has global coverage and localized directions. The route solver also takes into considerations things such as current traffic conditions and dozens of restriction types. If there are U-turns, any particular barriers, if you want to travel within a specific time window or time of day, other travel modes such as walking, and the order of the stops in which to travel. It can also calculate drive time areas, also known as service areas or isochrones. It can also find the closest facility to a point and generate an origin-destination cost matrix. Our routing services are used by many of the largest logistic companies in the world. If you'd like more information about the routing service, go to developers.arcgis.com and view the overview page. Here we have an example that's centered around Washington, D.C. This application allows the user to click once to set an origin and click again to set a destination, and then ask the routing service of ArcGIS Platform to provide directions. We've configured our API key to begin with. We're using the OpenStreetMaps version of Streets. And we've set up our route task. We've also added a click handler on the map to take our first click as our origin, our second as our destination, and then solve the route. In the getRoute function, where we're actually calling the routing service, we want to make sure that both graphics that we added to the map are sent to the service as stops. And we also want to tell the service to return the directions to us as part of the response. We send those parameters to the route task using the solve function. And then in our response, we can do two things. The first being take each individual line segment that represents a turn and add it to the map as a blue line. And the second, take every turn-by-turn direction and use the text to present back to the user each step as part of the directions. Now this is a very simple example, but it does show you as the developer the access that you have to the underlying data if you need to go further than this. All the information you need is right there. Let's take a look at another example. Rather than building that by scratch, let's add a directions widget to another sample, and this time we're looking at the City of London. So let's add in a code snippet that will set up our directions widget and add it to the top right part of the map. So rather than having to construct this all by ourselves, the out-of-the-box widget for the JavaScript API allows us to do something very similar in a much nicer user experience. Here we're going to set our origin to be west of London and our destination to be downtown London. Now you can see our route is automatically placed on the map. We have turn-by-turn directions highlighted as we mouse over each individual turn. And we can see it'll take about 26 minutes and about 20 kilometers. Now notice that's if we leave right now. And at this point, the time is set to about 9:59. Now let's say that I wanted to change that time and I wanted to depart tomorrow morning. I can change the date. I can change the time to be 7 a.m. And notice how the route has switched to take a more southerly route into the city. Now this uses the date and time window that you specified as part of the interaction with the widget to give you the most optimized results for driving time into the city. Likewise, you could also incorporate barriers. You could add stops. There's a lot of power packed into this widget that's ready for you to use with little to no coding. Finally, I'd like to talk more about those service areas. Service areas allow you to place a point on the map and determine in any direction how far you could travel. In our example, we're looking at downtown Chicago. If I point and click on the map, I get 3 areas giving me an idea of how far I could travel from that location. As we scroll through the code, we can see that on the click event of the map, let's take a graphic, put it on the map represented as our white circle, and let's create the areas in intervals of 5, 10, and 15 minutes. And from then, we're actually going to call that same route service, but we're going to say ask to solve for service areas. And our travel mode in this case is going to be drive time. And there's different travel modes that you can provide. So let's say since we're working in downtown Chicago, where a lot of people, the majority of people, will walk, let's change that to travel mode 5, which we know is walk time. If we save and change and update our application, we'll click in roughly the same area and notice how our service areas have changed. We now have a much more accurate representation of how far we could walk in 5, 10, and 15 minutes around the city of Chicago. Finally, I'd like to show you an example that takes in elevation into account when calculating a route. I'll click once in the city of Brig, which is located in the Swiss Alps. As I zoom out, you'll get an idea of the terrain that's surrounding the location that I'm interested in traveling to. As I zoom in to set my destination, I may want to get an idea of the travel time and distance along with the total ascent and the total descent that will be along my route. As you can see, the total distance is 196 kilometers. The total ascent was calculated at around 4,000 meters, and the total descent was calculated at around 4,300 meters. From directions to service areas and more, the routing service allows you to perform several types of spatial analysis on different transportation networks for different modes of travel. The ArcGIS platform also provides you with hundreds of spatial analytics tools and operators that can help you create understanding of your data, from geometric processing to attribute and spatial queries, and supporting interactive analytical operations on both 2D and 3D data. Now you can make use of spatial analytics in two ways. First, on the client side, by leveraging the power of the device resources so you can build highly interactive user experience. And second, by running analytics on the server, sending the data to the server where the tools sit right next to your information to get the job done. So let's take a look at a few examples. In this first example, we're going to analyze 911 calls from January 1st of 1998 to May 31st of 1998. And we're also going to send our data to the server for the geoprocessing job to execute. The geoprocessing job on the server then in turn gives us the results. And here we have two layers. The first being the points which you see on top of the map representing the calls from Saturday and Sunday. The second is the hotspot raster underneath the points that shows the density of where the majority of those calls came from. Sending your data to the server for geoprocessing will result in a much better user experience. The second example I want to show is how we can look at data information in 3D. And in this example, we're looking at a line of sight analysis. And here we're looking at buildings showing the existing layout of a city. We can see the line of sight represented in green that is not being impeded. And we turn on our proposed development layer. Right away, we can see that the buildings that are proposed to be built would interrupt or intersect with some of those lines of sight. As I move the origin for line of sight up and down, I can see at what level in the current building will a line of sight be retained. So not only can you perform analysis in the browser, but you can also do it in 3D. And finally, I want to show you just how far editing in the browser has come. Using the JavaScript API, I can create areas on the map by drawing a rectangle, extending it, moving it around very easily. I can also choose to create another feature that snaps directly to that existing rectangle. As I move my mouse, the point is automatically snapped to the edge, to the corner of that existing feature that I can then choose to build off of. As I move my mouse around, I can see angles start to appear to help me guide my new lines and my new areas. If I want to end back on another edge or another point of that existing feature, I can double click and my shape has been created. High performance and high accuracy editing can now be achieved directly within a browser application. And what you've just seen is truly just the beginning with regard to spatial analysis. The final location service we're going to talk about today is data visualization. And being able to visualize your data in unique ways is one of the strengths of ArcGIS Platform. We give you the tools to make beautiful maps and discover new patterns and relationships. And with new maps and location, you can visualize complicated problems. You can see the answers and then hopefully drive action. So developers have the capabilities and the tools to take data and quickly render features with an endless list of options and visualizations. You can visualize your data in 2D or 3D, as we saw earlier, using landscapes, cities, or even the entire globe. And through a technique called smart mapping, you can take the guesswork out of setting your map properties by automatically analyzing the data to make data-driven styling suggestions and create intelligent maps. And smart mapping applies to both 2D and 3D, and they can be used in just a few lines of code. This first example of data visualization puts a spin on the traditional way of showing a selected country on a map. And normally when a user points and clicks on a country in a map, that particular country is highlighted with a different color. In this example, an effect is actually applied to that country's geometry that allows it to blur and shadow and therefore stand out amongst all the other countries on the map. This is a unique way to engage your users and show them a way that hasn't necessarily been seen in web mapping. Another way to let your users interact with the data on the fly is using this example. This is showing median household income in Los Angeles area. The slider contains two lines here that indicates the values that we're looking for. One, the federal poverty level, and two, the low income threshold for a family of 4 in Los Angeles. As I move the sliders up and down, you see the map change dynamically. There are no calls going back to a server requesting more information. Everything is being processed in the browser in real time. What makes this possible is smart mapping with the ArcGIS JavaScript API. This same idea can also be applied to different data sets. Here we're looking at sea surface temperature for the globe. If you click anywhere in the oceans, you can see the sea temperature at that location. Here we can see the sea surface temperature was 11.63 degrees Celsius. Now that's not all we can do. We can also use this slider in the bottom left-hand corner to dynamically filter what we're looking at. So say we only want to look for temperatures within a specific range, maybe between 7 and 18 degrees Celsius. The map is immediately updated, and we're shown this once again in real time. This is the power that the web has now enabled us along with the ArcGIS JavaScript API. And finally, I'd like to show you a really dynamic application showing building construction in the city of New York starting in 1880. Let's move the time slider all the way back to the beginning and hit play, and let's see all the buildings that were built in New York over this period of time. Now as it's running, you can see different visual variables showing up on the screen that denotes when those buildings have been built. Now rather than having labels and cluttering up the map, we're simply using colors to represent age of the buildings of when they were built. If I hit pause on the map, we can see a light blue pocket that was built in 1948, which is the current year in which we stopped the timeline. If we look at the existing buildings, we can see that 20 years ago is represented by pink, and then darker pink further back. And as the time increases, the bright blue is always going to refer to the most recent buildings. So this way, we're showing a lot of information to the user in a way that they can easily understand and digest it. Today, we only scratch the surface of the location services that ArcGIS Platform can provide. With an extensive set of documentation, code samples, tutorials, and an active developer community just waiting, your next step is to dive even deeper. ArcGIS Platform can help you bring your ideas to life. Now, I'll hand it back over to the team for a poll question.
So what are the services that we just covered that interest you the most? Is it base maps and geocoding? And please select all that apply to you. Is it navigation? Is that hosting, that data visualization, or the spatial analytics? Seems like data visualization is the winner, with spatial analytics coming in a close second.
Thank you, Scott. Yeah, there's a lot of things that we just went through there. I know that was a lot. We started with generating an API key and onto base maps and styling and widgets and search. I think one of my favorites is the data visualization as well, especially the smart mapping with the live interaction with the histogram on that thematic data. Pretty amazing stuff. I think, you know, we've just saw all those powerful new features. I want you to think about how you can put those into action yourself. Really, what can you do with this, right? You can build a lot of different apps. So, you know, some examples here in the upper left, this map shows the total number of days over 95 degrees for every year between 1950 and 2099. This is coming from NOAA. This was built with the ArcGIS API for JavaScript that Adam was talking about, and this includes the capabilities of base maps and data hosting and search and data visualization. The example in the center, also using the JavaScript API, this is flow migration, and the data source here is the Internal Revenue Service, right? Not something you might think of traditionally, but a service out there that we tapped into, and again, using base maps, data hosting, and data visualization. And then in the bottom right, another great example, using here some census data. This is taking advantage of the American Community Survey with some data visualization and maps and data again as well. So there's a lot of different things you can do. You have to think about how you can combine the data sources that are out there and the tools together. Couple more examples here I wanted to share. This in the upper left and in the center, both leveraging the New York City open data, right? So we're using, again, base maps and routing and service areas in that first example in the upper left, like Adam showed to us here, doing a transit walk time. And looking at that and times from selected bus stops. In the center, we're looking at Wi-Fi accessibility, right? Using some different tools there to do a really nice service area and some spatial analytics. And then in the bottom right, we're looking at air quality awareness. So here we're using some data coming from EPA, from Air Now, and from NOAA, as well as Census, all mashed up together, right? Doing some really nice visualization. So these are just, again, some additional examples to get you thinking about what can you do with this? What do you need in your application? There are a lot of early adopters of the platform. There's some names here that are probably familiar to you, companies like SAP and Salesforce, but there's also some really interesting applications going on with companies like Airspace Link, right? They're fusing local data with demographic and geocoding services, producing a product that promotes safeness and compliant drone operations. So really pushing the envelope of what's possible. Now, we know the challenges working across national government organizations are many, right? We're all faced today with expanding expectations, demand for more information products near real time, right? I need it now. And yet it needs to be high quality, better quality data, maybe a higher, better resolution and granularity than what we delivered before. And of course, do all this, with smaller budgets and less staff and shrinking timelines. So these are not easy challenges to face. And we believe that by using the platform as a service, you can begin to address some of these key issues by improving responsiveness, for example. Again, we saw some great examples from Adam as well as the ones that I shared. Thinking about, in particular, the expansion of information delivery and improvement of our engagement with the community. Because we have these tools available to us, it really allows us to do that. So with that, I want to pause and thank you for your time today. We want to leave you with a lot of resources. There are a lot of things out there. We will post these slides afterwards with all of these great links for you. We encourage you to take a look at the resources pages and the getting started pages, as well as the Learn lessons. There's also some great content in the Learn ArcGIS platform. But with that, we want to throw it open to you for questions. So Scott, I'll throw it back to you to lead us through the discussion.
Thank you, Linda. Our first question is, are there ways to integrate R and Python notebooks within these workflows? Matt?
Yeah, that's a great question. Yes, there definitely is, because everything that you're basically doing inside, with all these services and everything are basically REST endpoints. You can pretty much hit them from any sort of server-side script that you have. So if you're using Python, you can definitely hit it from that. If you're using Java, you can hit it from that, even JavaScript. So any of those things are going to allow you to reach out and access that information. So absolutely, you can use it inside of Python.
Thank you, Matt. Our next question is, are there ways to allow users to download the results of a query, say on a point layer? Matt?
Yes, definitely. You can definitely do that. When you create a query, basically you're going to get a response from the service, right? You're going to get a response from that API. With the response from that API, you can then take that information and really do whatever you want with it. So when it comes back in, by default, it's going to be able to kind of feed your web app, or it's going to feed to whatever application that you're developing. But inside that application, you can then take that information and do other things with it. So yes, you can take that information and you can use it further in different ways.
Great.
All right, how do you see these services integrating with other tools like ArcGIS Experience Builder and Hub? Matt?
That's another great question. It does. It integrates directly. I mean, that's one of the great things about really this whole entire platform that we have is that everything works well together, right? So if you have information, you're already storing it on AGOL, or if you're using, Pro for a lot of your workflows, all this stuff works together and it really sort of integrates. So if you're using Experience Builder or if you're using Hub and you've got services that you're using inside of a web map that you create or something like that, those can be directly brought into your other applications as well.
All right, thank you, Matt. Our next question is, where will these slides be posted? We'll be sending out a follow-up email. These will be posted on the Esri communities page, but that email will be coming out next week sometime. Another question, could you explain more the difference between an API key and OAuth? Matt?
Yeah, so really this is one of the biggest changes that comes with kind of this PaaS solution. So it really actually gives you more flexibility that we now have the ability to do both an API key and the OAuth. So the way to think about it is if you have an API key would be something where you don't want to have a user log in or they're not going to need to access any of their own sort of private information. If that's the case, and maybe you just have an application that just needs to access base maps and access maybe routing, and that's it, then you probably just want to use an API key because you as the developer can go in and just specify that API key inside of it. But if you have something where it's going to be accessing users' content, so if it needs to access data that they've created or maps that they've created, and you want to do some sort of analysis on top of that, that's the time when you want to use that OAuth login instead.
Thank you, Matt.
Yeah, this is one of the biggest things, though, right, Matt? I mean, just the difference here with not having to have a named user, I think, is one of the most important takeaways.
It really makes it easier from the developer's point of view, right? If they don't need to access some of the really more complex things, this gives them a solution that they can integrate a lot easier.
Is there a way to calculate how much it might cost me to use Platform as a Service? Linda?
Yeah, there is actually, and I don't know if someone has the link, maybe we could post it into the chat. We can also post this as a resource afterwards, but we've created a great calculator so you can go out there and take a look at credit usage or storage, things like that.
And I've just put that in the chat.
Awesome.
Thanks, Matt. Thanks, Linda. Another question. I have an enterprise agreement already. Why would I use this? Matt?
So they really kind of work in conjunction with one another, right? So it's not really like an either or sort of thing. This is just another way that you can actually create things and deliver content to your customers. So even if you have an enterprise agreement, if you want to remove the ability to have to use the whole user login, you can do that through using this. So they work together. They're not really a separate thing.
Okay. Thank you, Matt. Thank you. Last question. I'm interested in hosting. How does that work?
That is another great question. That's actually one of the most powerful parts of this, whole ecosystem is the hosting, right? So if you're already using ArcGIS Online to store your information, as you may have seen in the examples earlier, it's really easy to take that data that you're already storing and you're hosting inside of ArcGIS Online and use that inside of your different APIs. So if you're making a JavaScript app or an Android app, you can usually access that information and bring it into your application with only a couple lines of code. So we've really made it easy for that whole entire integration to go. There's a cost associated with that, but if you take a look at the pricing link that we put inside the chat, that'll tell you kind of how the hosting works and what the prices would be for that.
Excellent. Thank you, Matt. Linda?
Great.
That's all our
thank
questions for today.
Yeah, thank you so much. That was great. And again, thanks to everyone who's joined us today. Really appreciate your attention and all the great questions. I think with that, we're going to wrap it up. Again, we will post everything out to GeoNet, into the community, the slides, the recording, the links. And please let us know if you have any questions. And if you can, take a minute to fill out the survey that we're going to leave you with at the end.